Hello. Welcome, everyone. Thank you so much for being here. This is part one of a two-part workshop with the amazing Christopher White, who's here with us from UMass Amherst to lead us through an exciting workshop on music and data. So thank you so much for being here. This is part of the Data Nexus series, part of the Data Fest programming for the weekend. I'm really thrilled that there's such a great turnout. I'm Morgan Patrick, I'm in the music department, and I'm thrilled and honored to be introducing Professor White, who's with us. So Chris White is Associate Professor of Music Theory at UMass Amherst. Chris received his PhD from Yale and has also attended Queens College CUNY and Oberlin College Conservatory of Music. Chris's research uses big data techniques to study how we hear and write music, which is the subject of his book, The Music in the Data. His forthcoming book, The AI Music Problem, 2025 Routledge, outlines how music presents uniquely difficult problems for machine learning and artificial intelligence. So please join me in welcoming Chris.
Hey, everybody. Whoa. It's really cool to see all of you here interested in such a nerdy thing like music and data analysis. I'm curious, how many of you like self-identify as a musician? If I said, hey, are you a musician? Would you say, I'm a musician? Yeah, okay. All right, so, and how many of you, if I said, you are like computer people, like you're a computer science major or something like that. How many of you are in that boat? Okay, awesome. So what we're going to do today is do some basic probability, do some basic ways of modeling data sets to talk about how surprising things are, what kind of chords move to what other chords, and differences between different data sets of music. And we're primarily going to be working with a data set of country music and a data set of R&B music. Now, in the email that Professor Patrick just sent out, there is a link for something, for this thing that you're looking at in front of you. And I would love everybody to sort of play along on their own computers with me through this hour and a half that we have together. So step one is to get to that link.
Can you raise your hand if you did not receive an email from me with this link? Okay, could I just meet with you in the back real quick so I can explain that to you?
Yeah, and if you don't have a computer with you, just like look over somebody else's shoulder is totally fine. We'll be doing group work together too. So what you should do so that we've got a clean copy, we keep a clean copy, is that you go in here and you go File and you press Make a Copy, and then you'll get yourself your own copy. So do that now. I'm even going to do that myself so that I'll keep this clean copy here. All right, Snap, if you've got that done. Thank you. Okay, so let me tell you about what you're looking at here. So this tab right here is about 10 country music songs that it lists the chords that are in the verses and the choruses. Where's the verse? What do we know? How do we know where the verses, where the choruses start? That's the zone. So that's column D is telling us whether we're in the verse or whether we're in the chorus, or the bridge. So V is for verse, C is for chorus, B is for bridge. And then chord. What you're looking at here are Roman numerals. And what Roman numerals are going to allow us to do is to not talk about like C in C major or G in C major or A dominant seventh in whatever, D major. it normalizes across key. And so if you're playing the home chord in a key, if you're playing C in C major or G in G major, that's 1. If you go further in the scale, so like what's after C in the scale? D. So if you're in the key of C major and you play a D chord, that's 2. If you play an E in C major, that's 3. And so there's this normalization across keys. So what we're seeing here is that in Help Through the Night, it starts with a 1 chord, so the first chord in the scale, and then the second thing that they play is the 4th chord in the scale. And then it goes back, then it goes to the 5th chord in the scale. That's what the Roman numeral 5 means, and then it goes back to the first chord in the scale. So that's what these Roman numerals are doing. And that's going to tell us the kinds of chord progressions that are going on in each of these songs. The first thing that we're going to do is see how often each of these chords are used in this data set. So to do that, I want to introduce you to a very useful spreadsheet tool called pivot tables. So go under Insert, and you'll see an option called Pivot Table. Click it. And then you'll have this option to create pivot table. Let's create it on the existing sheet. I'm going to put it right here. Create. So you're going to see something like this. I'd like you to add chord to the rows, and then what you're going to see there are all of the chords which are used in this data set. So you'll see something like that. Not something like that, you'll see exactly that. And then if we want to see how often each of those chords are used, I'm going to add values here. So go down to Values, Add, just add chord, because we're just going to count how many chords are in there. And now it's going to show you how many of each of those chords are being used. So you see that 106 times in this musical data set, these country folks are using, that sounded disparaging, the folks that are writing country are using 106 1 chords, 12 2 chords, 43 4 chords, 22 5 chords, and so on. Now, the Arabic numbers that are happening after this are added notes onto chords. So if you're playing a chord that's based on the 5th degree of the scale, and you add an added note that's an added 7th, it adds a little bit of a spice. That's what the 5/7 is. And so what you're seeing here are all of the clean chords which are being used, and then chords with added notes to them. And that's what the Arabic numbers are showing you, the notes which are being added to that chord. All right, let's turn these into probabilities now. So probabilities, well, actually, wait, let's do one more fancy thing with this. Let's sort by. So right now it's just like giving us an alphabetized version of chords or something like that. Let's sort by the count of it, and let's sort by the descending count. So you've got the most frequent chords on the top, descending down to the least frequent. So now we have our first observation of this musical data set. What chord happens the most frequently? The 1 chord, the first chord on the scale. What happens next most frequently? The 4 chord. After that, the 5 chord with a 7th in it, with some added spice to it. We feel okay with this? Thumbs up if you're with me. Awesome, you're beautiful human beings. Okay, now let's convert these into probabilities. Hey, Chris, what's a probability? Great question. my name's Chris. A probability is how relatively frequent each of these things happen. To make a probability, you take some sort of specific case and you divide it by the general case. The specific case divided by the general case. So like how probable is it that you get heads when you flip a coin? It's 50%. Because the specific case is heads, the general case is heads and tails. It's all flips. And so it's 50% probable because half of the outcomes are heads. So the specific case divided by the general case. The specific case here is going to be each of these individual chords. The 109 one chords are the specific case. The general case are the 228 overall chords. So what's the probability of a one chord? The probability of a one chord is going to be 106 divided by 228. So it's the specific case, the 106 one chords divided by the general case, the 228 all chords. So I'm going to make a copy of this little table right here, which I'm going to do by highlighting this table. I'm going to plop it right next to it. And I'm going to take the probability of my one chord by, here, I want you to do this with me. Press equals. So I'm right here, I'm going to press equals, and I'm going to click this cell, the 106 cell. Sorry. All right, so let's go over here. Let me label this probabilities. So the probability of this, so equals, that's telling the spreadsheet that it's going to calculate something. So you press equals, and then you take this 106 and you divide it by the 228. And you press enter. So right there, see how right there I've got equals, and then I've clicked the 106 cell divided by the 228 cell. Enter. There you got yourself a probability. Now I want to do this for each of these chords. If I wanted to do this super quickly, if you are doing a copy and paste, if I copy this cell and I paste it right down there, it's going to complain to you because it's now pointing it moves all of its references down when you copy and paste it down. We don't want it to do that. So in order to make it not change which cell it's looking at, we want it to constantly look at that 228. If you put a $sign in front of the G and the 14, it's not going to change that when you copy and paste it. So now I can take this and copy and paste it all the way down, and I've got probabilities for each of these all the way down. So there's a 0.46% probability that the country corpus is going to use a one chord, an 18.85% chance that it's going to be a four chord, a 0.14 probability that it's going to be a 5/7 chord, and so on. Now, the R&B tab, if you scoot down to the R&B tab here, you'll notice that this tab is formatted exactly the same way. It's just using a different style of music. I want you to convince yourselves that you can do this by doing exactly what we just did, but do it on the R&B tab. So I want you to find the probabilities of each chord in the R&B corpus. And I will circulate between tables in case there's any questions about what's going on here. So let's make this a 2-minute activity. Hey, by all means, work with the folks around you if you've got, if you're running into any problems. Okay, awesome. All right, let's now use average probability. Okay, so average probability is going to capture how ordered a set is. So if a few things are very probable, your average probability is going to be high. If everything is like equally improbable, your average probability is going to be low. So the intuition behind this is that if you have a coin that you flip and it's totally fair, your average probability would be 50% because everything's 50% out there. If you have a weighted coin where most of the time it comes up heads and almost never comes up tails, your average probability is going to be higher. Let's say your average probability is 0.9. The difference between those two things is going to capture how expected the outcomes are. You're more surprised by a fair coin than you are by a weighted coin. If you have a weighted coin, you should bet on it coming up heads. Like if you're in a casino and you've got a weighted coin, you should bet on heads, assuming that heads is where it's weighted to, because you're more sure of that. A fair coin, however, a 50-50 coin, you're less sure of the outcome. It's harder to bet on the outcome. So we use average probability in music data analysis to talk about how determined some kind of chord language is. So if a group of composers, if a group of songwriters is like doesn't care what chord they write, they just like write random chords, then every chord is going to be equally probable, and the average probability is going to be low. If they really like to write 1 or 2 chords, the average probability is going to be high, and we can say that there's a very constrained number of possibilities in a corpus. So how do we do this? Do this along with me. What happens if we just said equals average, and then we take the average of that whole sequence of probabilities? Well, we get 0.1, and that's not right. It's 0.1 because there's just 10 possibilities, and if you average any 10 possibilities, you'll get 0.1. So that's not the answer that we're looking for. The way that that you do average probability is to weight each probability by the amount that it happens. You weight each probability by the amount that it happens. So this 46%, this 0.46491, that the ratio that the one chord happens, that probability is taking up 46% of the pie. So 46% of your probability pie is this probability. So we want to weight this to take up 46.49% of our answer. Similarly, we want this 0.8885, et cetera, to take up 18.85% of our answer. So to do this, we're going to do equals this probability times that probability. So that cell times that cell. What that's doing is it's taking that probability and it's weighting it. It's making that size of the pie. And so we're going to do that all the way down. Everything here is, we're just multiplying it by itself, and then we sum it together. So now we're putting all of the slices of the pie together. And so the average probability for these chords is 0.2856. Now let's play around with this for a little bit. Let's imagine that we were in a world where this happened 0.9%, that one chord happened 90% of the time, and everything else happened, what do I need to do? 0.01, right? No, 0.011. So now, most of the time, you would see the one chord, and then very little bit of the rest of the time, you would see the rest of the chords. This is the situation like the weighted coin. Now, if we throw a dart at a dartboard, we're pretty sure that we're going to see a one chord. So our average probability should be higher. Let's sanity check this. Now we're going to do the same thing. Let's take the average probability of our like stupidly weighted chord syntax here, and we get a much, much higher average probability. Now let's imagine a situation where every chord happened the same amount, where your songwriter's like, well, I don't care what chord I write, I'm just going to randomly pick a chord. And then, so each of these chords would happen the exact same number of amount of times. So if there's 10 chords and they're all happening the same amount, what's the probability? 10%. Yeah, exactly. Right, because it's everything is happening the same amount. So let's see what the average probability would be if we do that. That times that. And the average probability would be 10%. So this is saying that this is a, so it's not a super duper constrained system, but it is much more constrained than a totally random system. That's what we're capturing here. Tell me whether the R&B corpus has a higher or lower average probability than the country corpus, please. And by all means, work with your table to do this. So you're going over and you're doing what we just did with finding the average probability here in the country corpus, and you're doing it for the R&B corpus. All right, so figure out whether the R&B corpus has a higher or lower average probability. So you should have gotten a lower number for the R&B corpus, right? Something like 0.17 something. Yeah. And so what does that mean? That means that there's a greater diversity of chords used in a more uniform manner in an R&B corpus. So it means that there's fewer chords being used in more constrained ways in the country corpus. That means that if you throw a dart at a dartboard in the country corpus, you're more, you can predict more clearly what chord you're going to hit. Versus the R&B corpus, it's less predictable. So the R&B corpus is less predictable than the country corpus. And we quantified that with average probability. Let's do transitions now. So now let's try to figure out which chords move to which other chords. So we're going to do a new pivot table. So insert pivot table. I'm going to put it underneath our existing pivot tables. Oops. This happened over there too. You got to make sure you have to be inside the pivot, your data set when you insert a pivot table, or it yells at you. again. All right, so when you get yourself your pivot table, we had before just chords in our columns here. Now, sorry, in our rows. And now we're going to add next chord in our columns. And that's going to look something like this, where you see that in this whole data set, 50 of the one chords go to other one chords. 28 one chords go to four chords. 7 one chords go to 5 chords, and so on. So I got there by having my rows be chord, my columns be next chord, and my values being the count of chords. Now let's convert this into a probability. One way that we can convert these into probabilities, well, let's do it the old-fashioned way, because after all, country is an old-fashioned kind of genre. So to convert these into probabilities, we do exactly the same thing as we did before, and we would take, let's do it, we'll take the, we'll say this, so we'll take this 50 and divide it by the grand total of that column, and then we will see that 47% of one chords go to the other one chords. And then we're going to do this for the remainder of this row. And I can do this for the remainder of this by $signing up the grand total there. Putting a $sign in front of the R, and then I can just copy this through the entirety of my table here, and then I've got a table full of probabilities. Another way to do this is to, instead of copying the whole table, you say, what am I showing my value as? I'm going to show my value as % of the row. And that'll do the same thing for you, just in a more quick and automated way. So % of row gets you the same answer. But I'm going to keep my counts up there for my own devices. So what this now allows you to do is say, what's the most frequent thing that a one chord does? Well, the most frequent thing that a one chord does is go to another one chord. And then what's the next most frequent thing? Well, you can go to a 4 chord. What's the most frequent thing after that? Go to a 5 chord. And so if you're writing a country song, if you're trying to build a robot that writes a country song, you could give your robot this to create a very, very simple chord progression, where your robot will most frequently write something that write one chords that then go to other one chords, and then maybe those one chords 26% of the time go to 4 chords, and so on. Convince yourself that you can do this by going over to the R&B tab and doing exactly the same thing. Make a chord transition table over in the R&B tab, please. And I will again circulate. All right, let's now use this transition table to... how about we do a... all right, let's do a little music composition thing. Can you write a 4-chord... So I want you to find a sequence of 4 chords that are extremely probable in one of these styles. So what you're going to do, for instance, I'm looking here at the country thing. If we started with a 1 chord, the most frequent thing that 1 chord does is move to another 1 chord, right there. So I could write 1, 1, could be my first 2 chords. Then I could take, what's the next most frequent thing that 1 chord would do? How about we move it to a 4 chord? Great. All right, so then I have 1, 1, 4. And then I would go down and say, what does the 4 chord often do? And I would look and see what the most frequent thing the 4 chord does. It goes to 1, and sometimes it goes to 5, 7. And so I could have 1, 1, 4, 1, or something like that. And that would be a very frequent thing in the country corpus. Can you write a very frequent chord progression in the R&B corpus? So use your transition table to find a very frequent chord progression in the R&B corpus, please. Yeah, why don't you start with 1? And don't just do 1, 1, 1, 1. Oh, and hey, let's be a good data scientist. Can you find the average probability of your chord progression too? So write a 4-chord progression and find the average probability of it. All right, so let's now do a technique called cross probability. Cross probability. So how surprised is, if you only listened to country music in your whole life, and then suddenly you heard R&B, how surprised would you be? Well, I mean, there's a variety of ways that we can quantify this, but let's look at it from the statistical perspective. So let's take, if we go over to our R&B tab here, and I'm gonna make up my little pivot table with chord probabilities. Also the pivot table. Yes. All right, so let's take the top 5 chords here. No, let's take the top 6 chords. All right, so if you go over to your R&B corpus and you take the top, let's take the top 6 probabilities. So the probabilities of the 1 chord, the 4 chord, the 5 chord, the 6 chord, the 2 chord, and the 5/7 chord. All right, let's take those. I'm gonna just plop those over here. So this is the probs from R&B. Now let's go back over to country, and I want to take these probabilities from country. So hop over to country here, and let's take the probabilities of these 4 specific chords here. So the probability of the 1 chord was this divided by that. The probability of here. So just to remind myself which chords these are. So the probability of the 4 chord was this one. The probability of the 5 chord is down here. Equals, hold on. Okay. So, again, so we want to pull over the probability of the 1 chord, the 4 chord, the 5 chord, and the 2 and the 5/7. So the probability of the 1 chord is this one. The probability of the 4 chord is 0.188. The probability of the 5 chord is 0.096. The probability of the 6 chord is 0.026. The probability of the 2 is 0.053. And the probability of, whoops, that's there. And the probability of the 5/7 chord is 0.144. So to find how surprising the country corpus is given the R&B corpus, we take instead of multiplying the these two, the probability by itself, we multiply the probabilities across each other. So we're saying that 46% of 46% of that the 1 chord is 46% probable, and it happens 31% of the time. So we multiply those two things together. Oh boy, that's a. Here, let's convert this into a percentage, and then it shouldn't yell at us. Percents. So it equals this times this. Enter, and then we would sum those together. And so we get this 21% probability. That's saying that that it gives us a number for how surprised the country corpus is given the R&B corpus. And so if you've got 2 different data sets, you can use average probability to quantify how surprising one corpus is by the other. I want to make sure that I show you a toy for talking about how another way for talking about how similar 2 things are today. In the email you got, there was a link for a Google Colab for clustering. When you click it, it should look like this. rcluster.ipy. Pull that one up. So I'm going to show you some fun things to do with these transition tables. So take this piece of code and just copy it, make yourself your own copy. So save a copy in Drive. So you take the R cluster, save a copy in Drive, save your own copy in Drive here. And what this is, it's a bit of code that's going to take in a table, and it's going to take each of the rows of that table, and it's going to tell you, it's going to create a visual representation of how similar each of the rows are. So what we need to do is first make a table on your home machine. So I'm going to take the transitions from Country Corpus, and I'm going to use my own favorite spreadsheet. I'm going to throw this over into Excel here. So throw it into an Excel spreadsheet, or whatever you use in your home on your home device for spreadsheeting. So what I did was I took the transition table of all the probabilities. So how often the one chord goes to the one chord, how often the four chord, blah, 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 that transition table. So take your transition table and save yourself your own copy on your home device. I'm going to save it, and I'm going to put it in a place where I can find it. And I want you to make sure that you save it not as an Excel spreadsheet, but as a CSV. So when it's save as, I want you to save as CSV. I'm going to just put it right in my documents so that I can find it easy peasy. Oh, I'll put it in my folder that I'm calling Elon. Why not? All right, now, when you open up this cluster program, it's a nice preloaded, pre-baked code that when you go and you press Run All, it's going to connect through, and it's going to ask you to choose a file. When you press Choose File, you then pull up that CSV that you just saved. So you open up that CSV that you just saved. And then it's going to think for a second. And it outputs this beautiful little picture. And what this is doing is it's treating each of these rows here so like all of these values that are associated with the one chord, all of these values that are associated with the four chord, all these values that are associated with the 5/7. It's seeing how similar that string of numbers is. and it's putting things together which are most similar. So it's saying that the 1 and the 5 chord have the most similar string of numbers. And then the next most similar thing to that is 4. And then the next most similar thing to that is 6. What it's saying is that the 1 chord acts most similar to the 5 chord. The 4 chord acts similar, but not as similar as those two act. These 2 chords then act the same. This chord sort of acts like these chords, and then these chords act like nothing else. They act on their own thing. What an agglomerative hierarchical clustering does is it tries to chunk things that look the same together, and then it chunks chunks of chunks, and then it chunks chunks of chunks of chunks of chunks to create these trees of increasing similarity. If you're having trouble with this, I'm going to circulate now. If you did this easy peasy, I want you to try this with the R&B corpus. All right, I'm gonna look around and see where everybody is. All right, let's do one more activity that does everything that we did today. So I want you to scoot back over to the classical tab. This is a corpus of things from like Beethoven and Mozart, so very different than R&B and classical. Can you? So let's imagine that you're, thrown into a data science lab, somebody gives you this and they say, hey, can you make a transition table? So that means getting how frequently each of the chords moves to each other chord. So make a transition table. I want you to find the average should we go that far? Make a transition table, find the probabilities, and then cluster that. Let's do that. Yeah, and then we'll call it a day. The classical tab, yeah. If you want to challenge yourself with one more task, find the average probability of each chord. So great question from this table here. Hey, there's no next chord. So you've been thrown into a situation where you don't have this next chord data available. So let's make it next. So next, you just say, hey, let's make it equal to the thing that I'm about to see. So next chord is just going to be the next chord in the sheet. So that's it. That's how you get there. You just make a new column, equals, instead of equaling the chord that's in that row, it's the chord that's in the next row. Now you've got yourself that data available to you.